Hello friends, welcome to the first video of this Java programming series, and in this video we are going to see a brief background history of the Java programming language, and then after that I will show you how to install the IDE which we are going to be using throughout this series, which is VS Code. So without wasting any more time, let's get started. First of all, what is Java? Java is a high-level object-oriented programming language designed to be platform independent. It follows a write once, run anywhere principle, meaning that Java code can run on any device that has a Java virtual machine installed in it. Now let's look at the brief history of Java. In 1991, Java was initiated by James Gosling at Sun Microsystems. In 1995, it was officially released as Java 1.0. It was designed for interactive television but found its niche in web applications. In 2006, Sun released Java as open source. Then in 2010, Oracle Corporation acquired Sun Microsystems, taking over Java's development. Till date, Java continues to evolve with regular updates and new features. So this is a brief history of the background of Java programming language. Now let's see a walkthrough of the installation of VS Code, which is the IDE or compiler we are going to use for our programs in this series. The first thing to do for installing VS Code is to open your web browser. I'm using Microsoft Edge for this demonstration, but you can search in any other browser that you have in your computer. In the search bar, search VS Code download for PC. And when you run the search, you are going to be directed to this page. You click on the first link provided. When the link opens, we see options for different operating systems, but I will choose Windows since that is what I am using. To choose a given version for your operating system, you simply click on the link below the operating system icon. Now, when you come to this new page, you click on download, which is found at the top right of the screen. If I check my browser downloads, we see that the download has already started, but I'm going to stop this download because I already have VS Code installed in my machine, so it is pointless downloading this again. Once the download is complete, click on the downloaded file and follow the few very easy steps which you will be directed to follow in order to install VS Code in your PC. Now in my home screen, we see that I already created a folder named Java Crash Course, and I also have my VS Code which is already installed. So I'm going to import my Java Crash Course folder into my VS Code simply by dragging and dropping it into my VS Code icon. Now that my VS Code is open, we are ready to start working. Okay, so let's get started with our Java programming. The first thing we are going to see is how to create a Java file. I will create a Java file named quickjava.java in which I will be writing my programs. To do that in VS Code, I can simply come to the new file icon when I hover on my folder which I already imported. I will click on new file and then give the file name as quickjava.java. There are two things you should note on this file name. The first thing is that the file name should begin in an uppercase character, and secondly, it ends with the extension .java. .java is the extension for every Java program, and it is what tells our IDE that whatever we write in this file is going to be some Java code. Now that we have created our Java file, let's look at the structure of a Java program. We will first declare a class named quickjava.java. I will do that by writing public class, and then the name of the class is quickjava. Every Java program must have at least one class, and the name of this class should be same as the name of the file in which we are writing the program, but it shouldn't have the file extension .java, just the name without the extension. I will follow this now by a set of curly braces. Now within our class, we have to define a main method which will contain the body of the program, and it is where the program is going to start executing. So I will simply do that by writing public static void, and then main is the name of the method. So this is something you just have to memorize. You don't really need to understand what all of this means, but just understand that we are creating a main method which is going to contain the body of our program. Now let's look at how we can print a simple message to the console in Java. In Java, we can print a message to the console using either the system.out.print method or the system.out.println method, which we are going to see right away. So let's first print a simple message which says hello world to the console. I will say system.out and then .println followed by a set of parentheses, and then in the parentheses I will put a set of double quotes. Now within the double quotes I will write the message which I want to print, which is simply hello world. Let me spell that correct. And then I will end this line with a semicolon. The semicolon marks the end of a line in Java. Now let's print a second message using the system.out.print method. So I will say system.out.print, and then this time around I will still follow it with a set of parentheses and double quotes in between. But this time the message I'm going to print will be hello Kevin. And then with a semicolon at the end still. Now I will print that message again, which still says hello world. Or let me change this to hello viewers. Now we can save this program simply by clicking Ctrl S on the keyboard for Windows users or Command S for Mac users. And then I can run this in the VS Code terminal simply by going to the three dots at the top of my VS Code tab. And then I will choose terminal, then new terminal. Now this terminal can permit us to run our Java program. I'm going to use a simple command for running the Java program, which is java c space followed by the name of our Java file, which is quickjava.java. I will say quickjava.java. Notice that the J in Java of quickjava is a capital J. So after writing this, I will press enter. Now we can see that a second file has been added, which is quickjavaclass.class. This is to show that the compilation is successful. Now I will type a second command, which is going to be java and then quick java, this time around without the extension .java at the end of the file name. And then I will press enter again. Now we can see our three messages which we printed in the program are displayed successfully. We see the first one, hello world, and then after hello world is printed, we are taken to the next line and then we print hello Kevin. But after hello Kevin, the second hello world is printed on the same line. This is because when printing hello Kevin, we use the system.out.print method instead of the println method. So this simply tells you the difference between both of them. When we use the println method, the message is printed and then we are directed to the next line immediately before printing the next message that is coming. But with the system.out.print without println, the message is printed and we remain on the same line before printing the next message. So if I simply add ln at the end of this print to make it to be a println method now, when we run this, everything is going to be on a new line. So I will save this again. And then to run the program, we don't have to type the same command each and every time. I can simply press the top arrow key to go to the most recent command, which is quickjava.java. And then I want to go to the command before this, so I press the top arrow a second time, which is java c quickjava.java. Now I'll press enter. So it is successful. I will now use the arrow keys again. So now we see hello world, hello Kevin, and hello viewers are each printed on a separate line. The next thing we are going to see in this video is comments in Java. Comments are text notes used to explain code and which are usually ignored by the compiler when running the program. In Java, we have two types of comments, which are single line comments and multi-line comments. Single line comments are simply comments that are written across one line only. For example, I can use single line comments by writing two forward slashes, and then whatever I write on this line, it becomes a single line comment. So I can say this is a comment. This is a single line comment. And then multi-line comments are comments that are written across more than one line. They can be written across one line as well, but the advantage they have over single line comments is that we can write them across multiple lines too if you want to. To use a multi-line comment, I will write a forward slash followed by an asterisk, and then everything after this becomes a comment. So we can close this comment by writing another asterisk and followed by another forward slash. So everything written between these two asterisks becomes multi-line comment. I can span this across multiple lines, and I will say this is a multiple line, or I'll just say a multi-line comment. Okay, so those are comments in Java. The next thing we are going to see in this video are variables in Java. Variables are containers for storing data values with a given name, which we can later access in the program just by writing the variable name. Some rules for naming variables in Java are: 1. The variable must begin with a letter, underscore, or $sign. 2. Variable names can only include letters, numbers, underscores, and $signs. 3. Variable names are case sensitive. This means that they must be consistent with the different upper and lower case characters in the variable name wherever the given variable name is written. Variable names cannot be reserved words or keywords in Java. Reserved or keywords are words that are inbuilt to the Java programming language to mean or do something specific. And the last rule for naming variables is that variable names cannot have spaces in between them. For any variable name which consists of more than one word, for example, if we have a variable named small boy, we are going to write the first word all in lowercase characters like small, and then for the next word we will write first letter in uppercase character, which is uppercase B, and the rest of the word in lowercase. So this is known as the camel casing naming convention. Let's say if the word was small boy test, the test will have a capital T and then the rest of its letters in lowercase character. So this is how to name variables in Java. Now note that each variable must be declared a data type. A data type is simply a word which indicates the kind of data which a variable can store. For example, we may specify the data type of a variable as int, meaning that this variable can only store integers or whole numbers. I am going to paste the list of the most common data types in Java which you will need to use most of the time along with some of their characteristics. The first common data type we have is the int data type. This stores whole numbers of size 32 bits over the range of approximately -2.147 billion to 2.147 billion positive. Now the next is long. This stores larger whole numbers of size 64 bits over the approximate range of -9,223 billion to +9,223 billion. The next data type is float. This stores 32-bit decimal numbers over the range of ±3.4e plus 38. The next we have is double. This stores 64-bit decimal numbers over the approximate range of ±1.7e plus 308. The next common data type is char. Char is used to store single characters of size 16 bits. After char we have string. String stores a sequence of characters. It can store from about 0 to 2 billion chars. And finally, the last one we will see is boolean. This is used to store values that can either be true or false. So above are the common data types we have in Java. Now that we have already seen the common data types in Java, let's actually see how to work with variables. So I will first declare an integer variable to store the age of a person. I will declare that by writing the data type, which is int, and then followed by the variable name age, a semicolon at the end. Now I will initialize the age variable with a value of 25. I will say age equals 25. Now let's use another variable. I will declare and initialize a string variable at once to store the name of the person. To do that, I will write the data type, which is string. Take note that for the string data type, it begins with an uppercase S, and then the variable name is going to be name, and I will set it to the value of Alice. Now let's print a message that displays the name and age variables. So I'm going to say name. When printing variable names, we don't have to write the variable names within double quotes. If not, they are going to be printed as normal strings. So to actually write it as a variable name, we have to write it out of the double quotes. This means that when this is going to be executed, the name here is going to be replaced by the actual value of the name variable, which is Alice. So I will write name, give a bit of space, and then I will say plus double quotes, and then I will say within the double quotes we are writing regular strings now, which is going to, I'll just say is. So my intention is to print Alice is 25 years old. So I have printed Alice. So take note that when printing the variable names within the same printf message as a regular string, we have to use the plus sign to combine these variable names with our string. This is known as concatenation. So I will continue my message. Now I'm going to write the h plus again, and then I will continue my string years old, and then full stop. Now I will add a semicolon at the end to mark the end of the line as usual. Okay, so we have the message name is h years old. Let's save and run this to see what the output looks like. So we see the message is displayed Alice is 25 years old. Now we are going to see another type of variables in Java, which are constants. Constants are variables whose values cannot be changed once assigned. In Java, constants are declared using the final keyword. So let's declare a constant to store the date of birth of this given person. So after declaring the age and the name, I will come below and then I will say final. Final is to specify that the variable which we are about to declare is a constant variable, and then the data type is going to be int. Variable name, I will give date of birth, and then I'm going to assign it the value of 2000. So we are in 2025 at the time of recording this video. It means for the person to be 25 years of age, that person should have been surely born in 2000 if we are following the years without taking into consideration the months. So I'm just going to make it simple by considering just the year. So now in my message, I'm going to modify this a little bit. I will say, so now the message is going to display Alice was born in date of birth, which is 2000. So she is age, which is 25 years old. So this should work correctly. I will save this and then run this again. So we can see the message is displayed. Alice was born in 2000, so she is 25 years old. That's exactly what we expected. Now let's try to modify the value of this constant variable date of birth to see if it is going to work or give a problem. So below here, I'm going to say date of birth equals, let me change it to 2002. And if I try to save and run the program again, we see that we are given an error in our terminal. Cannot assign a value to final variable date of birth. This is because we declared date of birth as a constant. So when we try to modify its value, it gives an error. Now if I remove this final keyword and make this a regular variable, let's see if it's going to give any error again. This time around, we have succeeded to modify the value of the variable date of birth to 2002. So those are constants in Java. Okay, now the next thing we are going to talk about in this video is casting. Casting is used to convert a variable from one type to another or from one data type to another. Let's see an example involving casting. I will first start by declaring a variable of type double called s, and I will set it to 3.2. Now I am going to declare another variable which will be an integer, and I will name it n. And then I am going to set n to s. So I am saying int n equals s, but this cannot work normally because s is a double variable or is of type double, while n is of type int, and we cannot take a value 3.2 which is a double value and assign it to an integer variable. So in order to assign this variable of the value of s to n, we have to convert s to an integer, and we can do that through casting. So to convert this double to an int, I am simply going to add a set of parentheses before the variable name s, like this, and then within this parentheses I can specify the type which I want to convert this variable to. So presently it's a double because we declared s as a double, but I can specify another data type within this parenthesis which I want to convert the variable s to. So I'm going to write int. This indicates that I want to convert the value of s to an integer because I want to store it in an integer variable called n. And note that when I'm converting the value of s, it doesn't mean the value of s will be permanently changed to an integer. It is still going to be a double variable as we declared it, but in this particular instance where we write this statement, it is going to be considered an integer. Now let me display the values of s and n. Okay, let's save this and execute now. So we see it is displayed s equals, oh, I forgot to write s here, so let me just correct this quickly and I'll run it again. So now we see it is displayed s equals 3.2 and n equals 3. This is because the value 3.2 has been converted to an integer value on this line in order to be assigned to the variable n. And when we are converting a double to an int, we simply ignore whatever is after the decimal point and we take only the whole number before the decimal point. So that is why n is equal to 3. So that is casting in Java. Now let us continue this video talking about operators in Java. An operator is a symbol or keyword that performs a specific operation or action on values and variables. The first type of operators we are going to see are arithmetic operators. Arithmetic operators are basic operators that allow us to perform arithmetic operations. So we have arithmetic operators in Java such as addition, subtraction, multiplication, division, and modulus, which we are going to see briefly in this video. So I already have my two variables s and n written down here, and I'm just going to declare a third variable which is going to be an integer m. So I will say int m and I will assign this the value 10. Now let's perform some arithmetic operations on these given variables. I am going to minimize this to increase space on our screen. Okay. So the first arithmetic operator we will see is addition. Addition is denoted with the plus sign. So we are printing the sum of m plus n. Since m is 10 and n is 3, we are going to have the addition of m plus n, and the result here is going to be 13. The next operation we will see is the subtraction operation. So we have subtraction m minus n. It is denoted using the minus symbol. M minus n. M is 10 while n is 3. So the result here is going to be 10 minus 3, which will be 7. Next we have multiplication. It is denoted using an asterisk to multiply two values. So I have m as 10 times n, which is 3. So 10 times 3 is going to give us 30, and that will be our result here. The next operation we are going to have is the division operation. It is denoted with a forward slash. And finally, we have the modulus operator denoted with a percentage sign. So the division and modulus operator are both used for dividing numbers, but they are different in their functioning. If we have an operation such like what we have presently, 10 divided by 3, given that these two values are integers, so let me precise int 10 and int 3. Normally in mathematics, when we divide 10 by 3 using the long division method, we get a result which looks like 3 and then remainder 1. So this is similar to what is happening between the division and modulus operators. The division operator gives us the quotient of the result only. The quotient of the result of 10 divided by 3, given that 10 and 3 are integers, is going to give us a quotient of 3 and a remainder of 1, because the answer is 3 remainder 1. So this is simply to say that when we use the division operator, it gives us only the quotient part of the result, while when we use the modulus operator, which is the percentage sign, it gives us only this remainder. So this means that on our example here, m divided by m, which is same as 10 divided by 3, it is going to give us a quotient of 3, while on the other line, where we have the modulus operator, 10 modulus 3 is going to give us a remainder of 1. So let's now run our program to see all the results being displayed. Okay, we see addition 13, subtraction 7, multiplication 30, division 3, and modulus 1 as expected. So those are arithmetic operators in Java. Now let's look at another type of operators in Java, which are increment operators. Increment operators are simply operators that increase the value of a variable by 1. There are two types of increment operator, which are postfix increment operator and prefix increment operators. The postfix increment operator increases the value of a variable after it has been used in an operation, while the prefix increases the value of a variable before it is used in an operation. Let's see the functioning of these two different types of increment operators. So I am going to use the variables m and n which we have above, and I'm going to write their sum. So here I am printing the sum of m and n, and then I will increment n afterwards. So the double plus symbols which I have written after the variable name n simply indicates that we are incrementing the value of n by 1, or we are using an increment operator on the variable n. So this is a postfix increment operator, meaning that I'm going to first perform this operation m plus n, and then after the operation is complete, I will increment n by 1 by writing n plus plus. So let's now print the value of n after the incrementation. Okay, let's save the program now, and then we will run it to see the result. So we see m plus n gives 13 because m is 10 while n is currently 3. So 10 plus 3 will give this 13 that we have, but we see that below when we have printed or displayed the value of n is displayed as 4. Let's print a more understandable message here. Okay, now let's quickly run this again. Okay, so now we see it displays m plus n equals 13, but sorry, I forgot to put m here. Okay, so we see it is displayed m plus n equals 13, but m is equal to 10 and n equals 4. How is this possible? This is because the value of n was initially 3, and then it is only after the operation m plus n was completed that n was incremented by 1 to give 3 plus 1 equal to 4 now. This is because we used a postfix increment operator, in which the value of the given variable to be incremented is only going to be incremented after the operation in which it is currently at is completed. Now let's use a prefix increment operator to see the difference between the two. So with the prefix increment operator, I'm going to first write my double plus before writing the variable name n. So this time around, I am saying m plus 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 n. This means that we are going to take the value of n, and then for n, we will first increment its value from 3 to 3 plus 1, which will give 4, before performing the whole operation of m plus n. So now let's run this again, and we are going to see how different the result is. Okay, this time around, we see m plus n gives 14, while m equals 10 and n equals 4. So this one gives a more accurate result. Okay, now that we have seen about increment operators, similar to increment operators, we also have decrement operators. Decrement operators are simply operators that decrease the value of a variable by exactly 1. There are also two types of decrement operators, which are the prefix and the postfix decrement operators. Their functioning are exactly the same as for increment operators in the postfix and prefix sense, but as we said, instead of increasing or incrementing, we are going to be decrementing the values with the postfix operator. So let's see, for example, I'm going to use a prefix decrement operator here. Instead of saying plus plus n, I will say minus minus n. This is a prefix decrement operator. So what it's going to do is that it is going to subtract 1 from the current value of n. N is currently 3, so 3 minus 1 is going to be 2. This means in this operation, the value of n is going to be considered as 2. Let's save this and run again. Okay, so we see the result gives m plus n equals 12 because the value of n is decremented by 1 as we said, where m equals 10 and n equals 2. Now let's make this a postfix decrement operator and see how different it is. So I'm going to say this time around n minus minus, and let's run the program one more time. First of all, I will save it. Okay, this time around we see m plus n equals 13, but m equals 10 and n equals 2. Normally 10 plus 2 is going to be 12, but since we use a postfix decrement operator, the operation was completed first. The operation m plus n was completed, and then only after then was the value of n actually decremented. So those are increment and decrement operators in Java. The next thing we are going to see in this video is how to take user input in Java. User input means we will make the program to take a value from the user while the program is already in execution and assign this value to a variable in the program. User input in Java is taken with the use of the scanner class, which we need to import at the top of our program. So I will come at the top before the definition of our class, and then I'm going to import the scanner class which we need to take user input. I will write import java.util.scanner with capital S. So this imports our scanner class. The import keyword is used to import packages or modules from elsewhere in our Java program, while util stands for utility, and it is a package that contains various utility classes and interfaces to help perform common tasks. From it, we are importing the scanner class, which is the class that permits us to take user input. Now, since scanner is a class, we need to create an object of this class before being able to use it. So I'm going to create a scanner object to read input from the user. I will write the class name first of all, which is scanner. So to create an object of a class, we need to write the class name first, and then I'm going to name this scanner object scanner serial, but this time with lowercase s, and then I'm going to say new scanner. The scanner here refers to the class name, and then I will open a set of parentheses and write system.in. Now we are going to prompt the user to enter your name. Now when we display the message enter your name, we are going to store this name in a string variable called username. So I will declare that variable string, and then user name equals, I'm now going to set this to scanner.nextLine, followed by a set of parentheses. So I am saying the username, which is the variable we have just created, is going to be set to scanner.nextLine. This scanner.nextLine is simply going to use the scanner object from the scanner class. So after the message enter your name is displayed, we are going to be taken to the next line, and there will be a prompt for the user to enter a value for the name. Whatever the user is going to enter as the name is going to be stored in this variable called username. The next line method is a method of the scanner class for taking string input only. Each data type has its own unique method for taking inputs for that particular data type. So here is a list of the different scanner class methods for taking different user inputs of different data type. For integers, we are going to use the next int method. For the long data type, we will use next long. Float, next float. Double is next double. Char, we are going to use next followed by parentheses and then dot. char at 0. And finally, boolean is next boolean. And for string is next line as we have already seen here. So now let's ask the user to enter their age. So I will change this message to enter your age. And then I will go below and declare another variable for the user's age, which is going to be int. And then I will do something similar to what I did for taking the name input. I will say scanner dot next, as we saw above. Next int is going to be the scanner method for taking int input. And then finally we are going to print a message which displays the user's name and age. So now what we have to do at the end is to close the scanner using the scanner.close method. So I will say scanner.close. Okay, let me now save this program and then we are going to run it. So the program asks us to enter your name. I'm going to enter my name, Kevin. And then enter your age. I will enter my age, 99. And when we run this, we see that Kevin is 99 years old is printed. So the program works exactly as we expected. And that is how to take user input in Java. Let's now talk about conditional statements in Java. As the name suggests, conditional statements are used to execute specific parts of our program based on specified conditions. The first one we are going to see are if statements. With if statements, we specify a given condition, and then if this condition is met, we will execute a given instruction or set of instructions. Let's see an example which involves verifying the score of a student in an examination. So I'm going to declare an integer variable for the score. And then I will set the score to 85. Let's assume this is 85 on 100. Now we are going to use an if statement to verify if the score of this student is a pass or a fail. So I'm going to write the keyword if followed by a set of parentheses. And then it is within this parentheses that we will write our condition. So my pass mark is going to be any mark from 60 and above on 100. So I'm going to say if score is greater than 60, then the student has passed. So I will put a set of curly braces after this. Within the curly braces, we can write what is known as the body of this if statement, or the set of instructions that are going to be executed if the condition score greater than 60 is met. Or let me rather say score greater than or equal to 60. It means if you have any mark which is 60 and above, it's a pass mark. So I'm going to simply print a message saying you have passed. Okay, now let's test this. We see the message you have passed is displayed in our terminal. Now let's change the value of the score from 85 to a mark below 60. Let's put 59. And then we will test it again. Nothing is displayed because the score is not greater than or equal to 60. So the instruction which displays you have passed is not executed. We can also specify another set of instructions which we want to execute if our given condition is not met. So we can have another block which is known as the else block, and the else block is going to contain a set of instructions or a given instruction which our program will execute if this condition score greater than or equal to 60 is not met. So I will simply go below this and then I will write else. It's also a keyword in Java, followed by a set of curly braces. Now I'm going to display another message here which says you have failed if your score isn't greater than or equal to 60. So let's simply copy this message here. I will change pass here to fail, and then we will save the program and run it. Now we see the message you have failed is displayed. This is better to write like this rather than not displaying any message at all. Now, one more thing we can do is that instead of having just one condition and then two possible set of instructions to be executed based on the result of the condition, we can also have multiple conditions at the same time, which increases the number of possible outcomes we can get. So this is going to be achieved by using some blocks known as else if blocks. We are going to do that in our program by simply coming after the first condition of our if statement. So I will come where the body of this if statement ends, and then below this I'm going to add another block. I will say else if, else, and then space if, another set of parentheses, so I can specify another condition here now. So let's say in the first condition I want to give grades this time around. So in the first condition I will say if score greater than or equal to 80, then we are going to print a message which says grade equals A. Now the second condition will be if score greater than or equal to 70. And if this condition is met, if your score is eventually greater than or equal to 70, it is going to print a message saying grade equals B for scores between 70 to 79. And then we can also add another condition again. Know that you can have as many else if blocks as you need in your program. So let me simply copy all of this. This time I will say if your score greater than or equal to 60, then your grade is equal to C. And then else you have failed. So we will leave the else just as it is. Now let me change the score this time around to 76. And then since the score is 76, the grade is supposed to be a B grade because 76 falls in the range between 70 to 79, and which is in the range of this condition if score greater than or equal to 70. So how this is going to be executed is that the program will start from the top, and then we will first check the first condition. If the score is greater than or equal to 80, we will display this message, and that will be all of it. The other conditions will not be tested anymore. But since this condition, the first condition greater than or equal to 80, is not going to be met since our score is 76, we are going to go to the next condition. If score is greater than or equal to 70, then the message grade equals B. Let me change this to B grade, it cannot be A. Grade equals B is going to be printed, and we will also stop from there without checking the other conditions again. But if this condition is not supposed to be met, then we will go to the next condition, and if the next condition is not still met, then we will simply print the message you have failed. So let's run the program to see what I'm talking about. So we see grade equals B is displayed. Excellent. The next type of conditional statement which we are going to see is the ternary operator. The ternary operator is a shorthand for the if statement. It is limited in that it can only be used when our situation requires only one condition to be tested. However, it can be very useful in such situations as it takes less time to write. Let's use a ternary operator to determine if the given student in this our example has passed or failed. So I'm going to declare a string variable to store the result. And then now I'm going to specify the condition. Let's write a set of parentheses first. Within the parentheses, I will write the condition to be tested. So the condition is score greater than or equal to 60 to determine if the student has passed. Now I will follow this with a question mark. After the question mark, I am going to write what is to be returned in case the condition score greater than or equal to 60 is eventually met. So if score is greater than or equal to 60, I'm going to return the string saying you have passed. And then after this, I will follow it with a colon, not a semicolon. And then after the colon, I will write the other message which is to be returned in case the condition score greater than or equal to 60 isn't met. So I will say you have failed in this case. Okay, so we see we have written our ternary operator. We end this with a semicolon as most other lines in Java to indicate the end of the operation. So here is our condition. We are checking if the score is greater than or equal to 60. If yes, then we return you have passed, and it's going to be the value of the variable called result. But if the condition score greater than or equal to 60 isn't met, which means the score will be less than or equal to 60, we will rather return the message you have failed. Now let's print the variable result to see its value. Okay, let's now test the program. And we see the program displays you have passed because our score is 76, which is greater than or equal to 60. Let's just change this to, let's say, 04. Now the program says you have failed because 4 is not greater than or equal to 6. Okay, so now let's talk about the switch statement in Java. This is the third type of conditional operator. The switch statement is suitable for situations where we have a single value which we want to compare to a number of alternative options. So let's see an example involving the use of the switch statement. This can also be referred to as the switch case or switch statement, but any of them mean the same thing. So our program is going to be a program that is used to display the names of the top 3 billionaires in the world as from January 2025 when I'm recording this video. So I'm going to declare a variable to represent the top billionaires, which is going to be a variable called top billionaire. And then I'm going to just leave it like this first. Now our objective with this example is to see the names of anybody who is among the top 3 billionaires in the world. So what we will do is I will write the switch keyword followed by a set of parentheses. Within the parentheses, I will write the value which I want to compare to other values. In this case, I want to compare the value of top billionaire. And then I will follow this with a set of curly braces. Now what will happen is that I'm going to use something known as a case. The case is simply a value which we want to compare our switch value to. So I will say case is a keyword. So I will now write a value for the case. Let's say 1. So we are going to compare if top billionaire's value is 1. If our top billionaire is 1, then we are going to print the name of the richest billionaire in the world, which is Elon Musk. And then after this, I will add a keyword known as the break keyword. Break is used so that if the value of top billionaire is 1, which is indicated by this particular case, we are going to display the message Elon Musk. We will stop comparing to the next values within our switch case condition, because since we have already found the value we need, we don't need to continue looking for it anymore. After the break, I can specify another case. Let's say case, this time around I will say 2 for the person in second position, and I will copy these 2 lines, paste them. So for the second richest person as of January 2025, as I said, is Jeff Bezos. I may be wrong with these names, but I just saw them on a random article online and I decided to use them. But again, I could be wrong. And for the third, I'm going to say case 3 and I will display the name Larry Ellison. Okay, now let's assume after comparing top billionaire to these 3 values, 1, 2, and 3, if the value of top billionaire is not found here, we are going to display a message which says the value is invalid. And to do that, we can use a block known as the default block. So I will say default. And then the default is what is going to be executed automatically if none of the above values for the different cases match the switch value which we are comparing. So if that is the case in our example, I'm going to simply print a message saying I don't know. Okay, now what we will do is let's give a value to our top billionaire. Let's say 1. So top billionaire is equal to 1 here. If you like, you could also decide to take this value from the user, but that is going to make this video too long and user input is not our main focus here. So let's just assign it a hard-coded value and we will now run the program. So we see, since the value of top billionaire is 1, it matches the value of our first case, which is case 1. And in that case, the first billionaire is Elon Musk. That is why we have printed Elon Musk, which is seen in our terminal, Elon Musk. Now let's print the second. Let's see if top billionaire was equal to 2. This time around, a different name will be displayed, which is Jeff Bezos. And now let's give a value which is not specified in our switch case. I will say 4 if I want to find the 4th richest person, since our program defines only the 3 richest people on earth. If I want to now find the 4th, we have no information about that, so our program will not be able to display a name. Instead, we will simply tell the person, I don't know. Now let's modify this our program a little. So I'm going to separate the top 2 billionaires and group them together, while the third is going to be alone. So let me simply change this. I will cancel these 2 lines after my case 1, and then I will say, so this time around we are grouping the first 2 cases, which is case 1, the first case in which the top billionaire value is 1, and the second case where the value of the top billionaire is 2. So if it is either 1 or 2, our message is going to print. Since we want to use one output for both these cases, we are going to display a message which can correspond or which can be valid for both cases. We cannot just display Jeff Bezos because Jeff Bezos does not occupy 2 positions himself. So I'm going to say this is a top 2 billionaire. It means this given person is among the top 2 billionaires in the world, and then I will leave the third one just as it is, case 3. So even if we have grouped these 2, we must not group everything. We can still decide to leave some ungrouped. I will leave this one, case 3, Larry Ellison, and then the 4th, if it is not 1, 2 or 3 but any other random value or value which is not specified, I will simply display the message, I don't know. Now let's save this and run again. I'm going to change the value of top billionaire to 3. So we see, since our top billionaire is 3, we are displayed Larry Ellison. But if it is either 1 or 2, let's try that. I will change this value to 2 this time around. So we see it has displayed this is a top 2 billionaire. So everything works as expected. Now we are going to talk about loops in Java. A loop is a programming structure that repeats a block of code until a certain condition is met. There are 4 main types of loops in Java which we are going to see in this video, namely while loop, do while loop, for loop, and augmented for loop. So let's see examples for each of these different types of loops. I am going to use each of these different loops to write a simple program that displays the multiplication table for a given number from 1 to 10. So let's start by declaring a variable to store the number which we are going to be multiplying. I am going to initialize the number to 5. Now let's start with while loop. A while loop is a loop which checks a given condition before execution, and the body of the loop is executed so long as the specified condition is met or not met as specified by the program. So we are going to use a while loop to display the multiplication table for our number from 1 to 10. I am going to declare another integer variable called I, which is going to be used for iterating through our loop. So I will just declare the variable for now, and you are going to see how we will use it throughout the loop in order to understand its use better. And I'm going to assign this to 1. Okay, now to use the while loop, you start by writing the while keyword followed by a set of parentheses, and then within the parentheses I will write my condition. My objective is to display the multiplication table from 1 to 10 for our variable called number. So what I'm going to do is I will say, since the variable I is assigned to 1 already, I'm going to give my condition as I less than or equal to 10. So the reason I am saying I less than or equal to 10 is because since I is already 1 and I want to make my multiplication table to range from 1 to 10, it means that so long as the value of I is between 1 and 10, the loop will continue execution. So this is the condition for this given while loop, and once the value of I is no longer in this specified range between 1 and 10, it means the loop is going to stop execution at that point. So I will follow this with a set of curly braces. and then within the curly braces we are going to write the body of the loop. So my objective is to print the multiplication result of our number by each number between 1 and 10. So I am going to display this multiplication table. So I have displayed the message number, which is 5, and then times I, which is 1 at this level, and then it is equal to number times I. So this is where the multiplication is actually done. Now what we have to do after this is we need to increment our variable I. As we already saw how to use increment operators, I will simply write I plus plus, and this is going to increment the value of I. So after carrying out the multiplication of number by I, which is 5 times 1, we are going to display that result. 5 times 1 is going to be displayed as 5, and then after that operation we are going to now increment I by 1. It means we are now incrementing I by 1, which means I is going to be 1 plus 1, which is going to be 2. So notice that this is done at the end of the body of our while loop, and after this the loop simply comes to an end. Now what will happen is that this is going to be executed once, and then the value of I will be incremented and the loop ends. But since it is a loop, its automatic behavior is that it is supposed to repeat itself multiple times again. So once the loop ends here, it is going to come back to the start and execute the same lines of code which are in the body of this loop. But during the first iteration, we incremented the value of I at the end of the loop with this line, I plus plus. So this means the loop will be incrementing. The value of I is no longer going to be 1 again, but it is going to be 2. Till it is going to reach a point where I is going to be more than 10, which is no longer going to satisfy this condition, I less than or equal to 10. And at that point, the loop is going to stop execution. So let's save this and want to see the result we get. So we can see our multiplication table displayed. In the first line, we have 5 times 1, which is 5. Next, we have 5 times 2, which is 10. 5 times 3, 15. 5 times 4, 20. 5 times 5, 25. Then 30, 35, 40, 45, and finally 5 times 10, 50. And after this, the program execution comes to an end. This is because, as we specified in our program, we keep executing this particular block of code so long as the condition I less than or equal to 10 is satisfied or is met. So as the value of I keeps on incrementing, as we can see down here, it is first of all 1, then 2, then 3, 4, 5, 6, 7, 8, 9, 10. And then after that, at the final level, we are going to increment the value of I by 1 again, which is going to be 11. And it is no longer going to satisfy the condition I less than or equal to 10. So that is how to use a while loop. Now let's see how we can write this our same program using a do while loop. A do while loop is a loop which starts executing the body of the program at least once before checking the given condition. So let's see how we can modify this same program to be written with a do while loop instead. So in order to use the do while loop, I will simply cut this part, and then I'm going to start the loop with the keyword do. And then after do, we follow it with a set of curly braces, and within the curly braces we'll write the body of the loop, which is going to be same as what is already there, what was with the while loop. And then the difference is that it's at the end of this loop, after the closing curly brace for the body of this loop, we are going to now put the condition which is to be checked. Do all of this while I is less than or equal to 10. So we put the condition at the end instead. That is why it is a do while loop. We do first, we do by executing the body first before checking the condition. This means that since the condition is checked only after executing the body of the loop for the first time, it means the body must be executed at least once regardless of if the condition is met or not. So for this our particular program, the result is going to be same as that of the while loop because the logic of the loop is still the same. The only difference is how it is structured, meaning that we first execute the body once before we check the condition. So now let's save it and run again. Okay, we see that we still get the same result. 5 times 1 equals 5 down to 5 times 10 equals 50. But the structuring of our loop is different this time around because the way we use the do while loop is slightly different from the while loop. Now let's see how to do the same thing which we have already done here with the while loop and do while loop, but this time around with another loop called the for loop. So the for loop simply permits us to keep executing a particular block of code for a fixed number of iterations. This loop is best for iterating over a range of given values. So let's see how to achieve the same result for this our program but using the for loop this time around. So for the for loop, I will write the keyword for followed by parentheses. And then now instead of just writing the condition within this parenthesis like we saw with the other types of loops, it is going to require some more things. So I'm going to first start by writing the first thing in the parenthesis, which is going to be the initialization condition. So I'm going to specify that my value of I is 1. I could still modify the value of I and put another value like 2. I could modify the value of I here, but since we want to multiply our number variable by all the integer numbers between 1 and 10, that is why we will maintain the value of I, which is 1. Now here is where I will specify the condition to be checked. My condition is going to be same as in the other loops, which is going to be I less than and equal to 10. And then now I'm going to put the increment statement, which is I plus plus. So in the while loop and do while loop, we put our statement I plus plus at the end of the body of the loop, but in the for loop, we put it at the beginning of the loop instead. Now follow this by a set of curly braces. Within the curly braces now I will write the body of the loop, which is the same body as we already saw in the other types of loops. Okay, so now we come to the end of our loop in the next line. We don't have to write I plus plus like we did in the other loops again like this because we have already done that here at the beginning of the loop. So this line is not necessary. And then another thing you should note is that with the for loop, you can actually declare this our variable I within the for loop itself. So I can simply remove this line from here, or let me actually just comment it first, and then I can say my int. So I'm actually declaring the variable I within this particular for loop only, and this is still going to work, but I prefer actually declaring the variable I out of the loop. This is because by doing this way, we can have multiple for loops and we simply use the same variable I rather than declaring it for each different loop. You can do any one that you want, but this is my personal preference. Now let's run the program to see the result. And we see the result is displayed, which is same as the result for the other different loops we have been seeing. So that is how to use for loops in Java. We are going to see more about the other type of loop, which is the augmented for loop, shortly in this video, because I want us to first of all talk about arrays before seeing that particular type of loop, since it is best to use it when working with arrays or other sets of values like arrays. Hello friends, in this video we are going to talk about arrays in Java. So before we start using arrays in our program, I want to first take some time to explain what an array is. An array in simple terms is simply a variable, a sort of variable which can be used to store multiple values at a time. By multiple values I mean more than one value. Let's say if we have a regular variable of type string which is called food, and this variable is going to store the name of a given food. For example, let's say mango. This is a variable which stores the value mango. Now what if I wanted to store maybe the names of different fruits within this same variable? Instead of just mango, I could want to store maybe mango and let's say apple. Now this isn't correct to do this because a variable by default can store just one value, but we can accomplish this using an array. So we are going to declare an array and then we assign multiple values to that given array as we want. So now that you already have a small understanding of what an array is, let's see how to actually use it in our program. The first thing to do when we want to use an array is to import the array class, which is an inbuilt class in the Java programming language. I will do that using my import statement by writing import java.util and then .arrays. Take note it has an S at the end. So this imports the array class, which contains various methods for working with arrays in Java. Without it, you can't use arrays in your program. Now let's see how to declare an array. To declare an array, you start by writing the data type of the array elements, because in Java, arrays store elements of the same data type only. So I want to declare an array that is going to store the names of multiple fruits. So the type is going to be string. And then after the data type, I'm going to write a set of square brackets. This indicates that this variable is going to be an array instead of just a regular variable. And then I will write the array name, which is fruit, with S, because I want to store multiple fruits. Now this is the array declaration. Let's now see how to initialize the array. To initialize the array, I will simply write the new keyword and then followed by the array data type, which is still string, followed by a set of square brackets again. But this time around, I'm going to write a value within the square brackets, and this value is simply going to represent the size of the array. For the sake of this example, I will give the size of my array to be 3, and then after that, I will end my line with a semicolon. So the size of the array simply indicates the number of elements or values which are going to be stored within this given array. Now let's look at how to assign values to array indexes. An array index is simply a position within the array. So since we have an array of size 3, it means there are 3 positions where we can store elements within this array, and these positions are simply called indexes. By default, indexes always begin at 0. That means the first index is going to be 0, the second index will be 1, and the third index will be 2, and so on if you had an array of size more than 3. So a simple formula for knowing the last index of an array is simply by taking the size of the array and subtracting 1 from it, because when we start counting from 0, the last index is never going to be exactly the size of the array, because we don't start counting at 1 but rather at 0. Now let's see how to assign values to this array. We are going to assign the array values using the indexes, and to do that, let's say if I want to assign a value to the first index of the array, which is index 0, I will simply write the array name fruit and then followed by a set of square brackets. Within the square brackets now, I will specify the index at which I want to add the given value, which is index 0, meaning that the value which I'm going to assign is going to be the first value in the array, and then I'm going to assign it the value of apple. So apple is the first value in our array. Let's add other values at the other indexes. So at index 1, which is the second value in the array, I will give the value mango, and the third value is going to be at index 2, which will be banana. So these are my different array elements. Let's now see how we can display this array or the array values in our console. Now, if you want to display the array, an easy way of doing that is using the arrays.toString method, which is a method provided by the arrays class that enables us to display the elements of an array at once as a contiguous block. So to do that, I will write the arrays, which is the name of the arrays class in Java, and then .toString. ToString is a method provided by this array class, followed by a set of parentheses. Within the parentheses now, I will write the name of the array which I want to display, which is going to be my fruit array, and a semicolon at the end. Remember that. Now let's save this and we will run our program to see our array being displayed. Okay, we see our array is displayed as a contiguous block as I was talking about. We have apple, mango, and banana. These are the various elements which we stored in the array. Now let's see how we can use a loop with an array. We are going to use a for loop specifically because this is the best type of loop for working with arrays. And after that, I'm going to show you how to use the augmented for loop, which we do not see in the section about loops, because I wanted to keep it for this particular section, since the augmented for loop is designed specifically for working with collections such as arrays and other collections provided in Java. So I will comment out this line. Now let's see how to use a for loop to display the array elements. The advantage of using a loop with an array is that you can do many other things instead of just printing the array elements, because as you can see, we can use this to string method and it already does a good job at printing the elements. Even though what we are going to do is simply printing the elements of the array, with a loop you can do many other things. So I have initialized my loop to start when I is equal to 0, and it is going to run so long as I is less than 3. That means when I becomes equal to 3, the loop is going to stop execution. And the reason I am doing that is because our array is of size 3 and there are only 3 elements within the array. So it is going to run when I is equal to 0. In the second iteration, I will be 1, and in the third iteration, I will be 2. All the 3 elements of the array will be displayed already. In the fourth iteration now, I is supposed to be 3, but the loop is not going to continue execution at that point because of our condition we have precise here, I less than 3, meaning the loop should run so long as I is less than 3 only. Now I am going to write the body of the loop, which is simply going to be a simple print method printing the different elements of the array. So what we are going to do is we will write the array name, which is fruit, followed by the square bracket still, and then within the square bracket we are supposed to specify the index which we want to display. But since this is within a for loop, and the for loop has this variable I which is going to be changing values at every iteration, we can simply use this to access the given element at a given index at every iteration of the array. So I'm simply going to put I. In the first iteration, I is equal to 0, meaning that the value of I is 0, and when we say fruit of I, it means this is equivalent to saying fruit of 0, and we know that fruit of 0 is apple, so the value apple is going to be what is represented by this whole statement, and that applies for all the other indexes and values within our fruit array. Now let's save this and we are going to check the output. We see the various array elements are displayed one by one this time around: apple, mango, and then banana. Now let's also see how to use an augmented for loop instead of a regular for loop. So what is going to change is going to be this first line of the loop. So when using the augmented for loop, what we are going to do is, since the array is of type string, I'm going to declare string variable, which is going to be string. I can name this anything, which is, I will just put X for the moment, and then I will put a colon. After the colon, I will write the array name, fruit. So what this means is we are simply saying for string X in fruit. So you can simply read this as in, meaning that we are declaring this variable X, which is going to contain the value of all the different elements within the fruit array one by one at every iteration. That means in the first iteration, it is going to contain the value of the first element in the fruit array, which is apple, whereas in the second iteration, it will be mango, and the third iteration, it is going to be banana. So this is already set by default to loop through the array one element after the other every iteration. And you can see that when using this type of loop, you don't even need to know the size of the array, because when you just say for X in fruit, it is going to automatically know that it is supposed to loop through the whole array from start to finish. So here we don't need to specify any exit condition for our loop. And then what you need to note is that this variable X which you declare here is supposed to be of the same data type as the array, because it is going to be storing the values of the array. In order to do that, the data types must be the same. For example, we cannot make this an integer, because an integer cannot store string values, since we know that this variable is supposed to store the different values of this array at some point. So this is supposed to be a string, or whatever the data type of the array is. We can give this any name so long as it follows the rules for naming variables in Java. And I would prefer to give it a more descriptive name like fruit, this time around without the S, to specify that it's a single fruit, so that it should make more sense to say for fruit in fruits instead of just giving a random name like X. And then now to display the elements, we don't need to specify the index, because here we are not using indexes with the augmented for loop. So I will cancel all of this. And then I will simply write the name of this variable fruit, since we already know that it is what is going to be storing the values of the different array indexes. I will just write it here, fruit. So at each iteration, fruit is going to store a given value of the fruit array one after the other. And then at each of these iterations, we are simply going to display the value of this fruit below here. Now let's save this again and check our result. and we see that we still get the same result: apple, mango, and banana. Now what I want to show is how we can declare an array and initialize the array values at the time of its declaration at once, instead of first declaring the array and then assigning its values afterwards. So in order to achieve that, I'm going to modify this our program a little. Now we are going to declare our array, which is going to be the same array of fruits. The type is still going to be string, and then fruits. Oh, and then I must not forget the square brackets here. They are still necessary. Now I will set this equal to, instead of saying new string and then specifying the size of the array again, I'm going to simply write the elements which I want to store within the array at once. And to do that, I will write a set of curly braces. Within the curly braces, I will immediately write my array elements, which are going to each be separated by a comma. So since they are strings, I will write them within double quotes. The first fruit is going to be apple, comma. I will write the second one, which is mango, comma, and then the third one, which is going to be banana. And then here, since we have not specified any size for this array, I can even add a fourth one, and the fourth fruit I'm going to add will be watermelon. I hope that's how it is spelled, I don't know. And then I will put my comma at the end. So this is an array. This time around, our array is of size 4, which means it has 4 different values. The size of the array cannot be modified after it has already been declared and initialized. So here, when we have an array of 4 elements like this, it is not possible to modify the size of this array laterwards, but we can only modify the values within the given array indexes. So I can still come here, and then let's say if I want to change the last value watermelon, I'm going to change it, and I will specify array of the index of the last element is going to be 3, since the array is of size 4. And then I will set this equal to a new value. The value I'm going to give here is going to be, let me say, lemon. So even when you assign the array values at the time of its declaration, you can still decide to modify an individual value afterwards. Now let's save this and run our program again. Okay, we see all our array elements displayed: apple, mango, banana, and lemon. Perfect. So guys, that is how to use arrays in Java. Hello friends, now we are going to talk about array lists in Java. So what is an array list? An array list is similar to an array, which is used to store multiple values within a given name. But the main difference is that an array list is a resizable array. This means that it is an array which does not have any fixed size, meaning that we can remove elements from the array and add new elements at any time we want in the array, and it is not going to have any problem. I mentioned previously that arrays are of fixed size, meaning that when we declare and initialize the array already, we cannot modify its size again. That is why array list is here to solve that given problem, meaning that it is going to also store multiple values, but we can decide to modify the size of the array list by adding or removing elements at any time we want. Also, array list comes with default or inbuilt methods in the array list class, which makes manipulation of the array list very easy. That means it has methods for doing many things easily, like adding and removing elements and so on. So to get started using array list, we need to import the array list class too. Import java.util and then .array and then list. Now let's create an array list. So to declare an array list, the first thing we write is the array list keyword, array list, and then after that I will write a less than followed by a greater than symbol. Within these two symbols, now I will specify the data type of my array list. Just like an array list only stores elements of the same data type. So all the elements in the array list must have the same data type, which we are going to specify here. And the array list I want to create is going to be an array list that it will store the names of different fruits. This means it's supposed to be a string. Now I'm going to give it a name, which is fruits, and then I will set this equal to new array list followed by a less than and greater than symbol again. I don't know if there's any given name for this, but I will just call them less than and greater than symbols, and then a set of parentheses now. So here we have declared and initialized our array list. Now we can get started adding elements within this array list. So to add an element within the array list, and one thing to notice is that we have not specified any size at any given point here. So we have just declared our array list and initialized it with the new keyword. But now let's add elements within this array list. So to add an element, I will simply write the name of the array list, which is food, and then I will use the dot add method. This method is already inbuilt in the array list class, which we imported here. So I'm saying array list dot add, and then I'm going to simply specify the value which I want to add into this list. The first food I will add will be apple. So this simply adds a value to our array list. Let me add two more food to the list. You can see that here we have not specified any index also before adding any value. The second food will be mango, and the third food will be banana. Now that we have added the different values to the array list, let's print out this list to display its values. I'm going to use my augmented for loop to do that. So as I said, this variable food is simply going to enable us to iterate through this array list, and at every iteration it is going to store a given value of this fruit array list. This means at the first iteration the value of fruit is going to be apple, and then the second iteration it is going to store mango, and the third iteration it is going to be banana. This means to print the different values of the array list at each iteration, we can simply access these values by writing this food variable. Now let's save this and we will run our program. We see we are displayed apple, mango, and banana. Now in order to display the elements of the array list, we don't even need a loop. If you want, we can simply display the elements by writing the list name within our system.out.println method. So to display the elements or values stored within this array list, it is as simple as just writing the name of the array list. But before that, I will write a small string which says fruits and then colon, and then I will simply concatenate the name of the array list fruits. So we see that just by doing this, we are able to display the values within the array list. That is what I'm going to show you now. So we see fruits, apple, mango, and banana. Now let's see some other methods which come with this array list class that can enable us to work with our array list. We have already seen how to add elements into the array list using the add method. Now let's see another method which enables us to get or see the value stored within a given position in our array list. So I'm going to write the name of the array list, which is fruit, and then I will say dot get. After the get, a set of parentheses. So within this, I can specify an index which I want to get. So if I specify any index here, this dot get method is going to go into our fruits array list and then return the value which is at the given position which we are going to specify here. So for example, I want to get the element at index 1, which is going to be mango. Remember that indexes always begin at 0. So if I put 0 here, it is going to get the first element, but if I put 1, it is going to get the second element instead. And I've put this within a system.out.println method so that it should actually print this value in our console. So let's check our result. Okay, we see we first display the array list as we have in our program, and then this is what we are interested in now. We have gotten the element at index 1, which is mango, as expected. Now let me show you how we can get the size or the total size of the array list. So I'm going to simply copy this and paste below, and then since this time around we want to get the size, we are also going to print it. That is why I've written it within strings method, but what we are interested in is the size method. So I will say fruits, which is the name of the array list, and then dot size. This is going to return the size of the array list, and it does not take any argument. So let's save this again, and we check the size. We are going to check for the size of our array list, and we see that the size of the array list is displayed as 3 because there are 3 elements precisely in the array list. Now, the last array list method we are going to see in this video is how to remove an element from the array list. So to remove the element from the array list, we are going to use the remove method, and we will do that simply by writing the name of the array list fruit and then dot remove. This is another method inbuilt within the array list class, dot remove, and then now I will specify the element which I want to remove from the list. The element I want to remove, double quotes, is just because it is a string. If it was an array list of integers, I will not need to put double quotes. Let's say I want to remove the element banana. I will simply write banana, and this removes banana from our list. Now after removing this, I want to display the list for us to see the list after removal. So after we have removed banana, we will display the list one more time to see if banana was effectively removed. So this time around, I will say fruit after removal of banana. Now let's run this again. Okay, we see we first displayed fruits in the first place on the first line, and then here we have the other outputs of the other operations we have been doing. This one is we got the value at index 1. Here we got the size of the array list, and then here we have fruits after removal. This is what we are actually interested in now. Fruits after removal of banana, we have just apple and mango because we removed the value banana from our array list. Okay guys, so that is how to use array list in Java. Hello guys, now we are going to talk about methods in Java. So a method is simply a block of code that performs something particular. For example, when we were seeing how to use array list, we had various methods from the array list class, like a method to remove an element from the array list. So what is happening is that when we write maybe the name of the array list and then dot remove and specify the element to be removed from that array list, there is actually a sequence of lines of code in the background that have been written in order to perform that operation of moving the elements to the array list. But now with our own methods, our own custom methods, which we are going to be creating ourselves, we are going to be the ones writing the actual logic that is in the background of the method. So what is the use of methods in our program? We may use methods to perform specific operations in our program and then simply call these methods to execute these specific operations which they have been designed to perform when we need them. An advantage of using methods also is that they are reusable, meaning that once you declare or define a method, you can use it as many times as you want in your program. Now, as you can already see within this our Java program, this is just the basic structure of a very basic program in Java, but this already contains a method because within our quick Java class, we already have this method which is the main method. So this main method is the method that contains the body of our program, and everything within the main method is what is going to be compiled and executed by our IDE. But we can also create our own methods within this same program. The only difference is when we want to create a method, we will have to actually create the method out of this main method because you cannot have one method within another one. So if we want to create a new method, we are going to go out of the main method and we create it out of this main method, but it should still be within the quick Java class. Notice that these yellow curly braces represent the class, while the purple ones represent the main method. Now I'm going to create my own method, and the method I want to create is going to be a method that compares two integer numbers, and then returns the maximum of these numbers. So to get started creating the method, I will write public static. Notice that it begins same as our main method also. So public static, and then after that I will write the data type or the return type of the method. The return type is simply the data type of the value which is going to be returned from our method. So let me finish the method, and at the end you will understand better what this return type is. So for this example, my return type is going to be int because the value I'm going to be returning will be an integer. And the name of the method, now this is where we write the name of the method. The name of the method is going to be find max, which simply means find the maximum. And now I will follow this by a set of parentheses. Within the parentheses, now I will write or specify the parameters of my method. The parameters of the method are simply values which will be required when calling the method, and these required values are going to be used within the method to perform the given operation which we want to perform. So my parameters are going to be two integer values. One is going to be named A and the other one will be called B. And by the time we finish this small example, you will understand everything better, so just be patient. So what I want to perform in this method is to find the maximum of two values. These two values are our two parameters which we have specified at the method declaration. So I'm going to use a ternary operator in order to compare these two values and return the max. I will store the max in an integer variable called max. So I will say int max. And then since I want to use a ternary operator to compare these two values, I will simply write my parentheses, and then the condition is A greater than B. If this is true, I'm going to return A. If not, I will return B. So max is going to compare A and B. If A is greater than B, then the value of max is going to be the value of A. But if A is not greater than B, max will be B. I already did a video on ternary operators. You can go back and check that video if you don't understand what is going on here. I promise with that video, you will understand ternary operators very well, but that is not the main aim of this video. So we are going to return the max now. You can also use if-else statements to compare A and B if you want. So max is an integer because its data type was int, and we are returning max. So this is what guides us to determine the return type of our method. Since we are returning max, which is an integer value, it means the return type of the method is supposed to be specified as int. If you were returning a variable that is, or a value that is a string, the return type of our method would also be string. But in order to achieve what we want in this given example, we are supposed to return an integer value. Now we have declared our method, and if we try to run the program, let me save this and then I will try to run this program. We see that we don't have anything returned in our result. This is because we have just declared a method but we have not called it. Now every custom method which we declare or create in our program must be called within the main method. As I said earlier, the main method is what stores the code that is going to be compiled and executed by the IDE or compiler. So when we have declared this method and initialized or done everything we want with the method, we are supposed to call it for it to have an effect. So in order to call the method, I'm going to initialize a set of variables, integer variables. One is going to be num1, which will be set to 2, and I will have num2 equal to 3. I just prefer giving a bit of space. Okay, now we are going to compare num1 and num2 to see which one has a greater value. So I can simply compare num1 and num2 if I want. I will say result to store the value of the result, and then I'm going to also compare num1 greater than num2. So here I'm comparing num1 and num2. Whichever one is greater is going to be stored in our variable called result, and then here below, on the line below, I will simply print the value of result. Now let's try to run our program again. So we see result is 3 because after comparing these two values, num1 equal to 2 and num2 equal to 3, num2 which has the value 3 was just be greater than num1 which has the value 2. And here we have our expected output. Now we have the expected result, but this is not what we want to do, because by doing this we have not actually made use of our method which we created, called findMax. We have written the logic by ourselves a second time again, and this is what methods try to avoid. They try to avoid unnecessary repetitions. Like here we already have our method which compares two values, and then it is going to return the maximum of these two values. So it's unnecessary to compare our two numbers here again. So I'm going to cancel all of this and replace it by our method. Now we have result. Instead of writing the comparison of num1 and num2 again, I am simply going to call our findMax method by writing the method name findMax and then followed by my set of parentheses. Now I'm going to pass the two values which I want to compare, which are num1 and then num2. So you see that num1 and num2 are our two values which we are going to pass, and the values of num1 and num2 are going to be the values which will replace this int a and int b, which we specified as parameters for our method. But when we specify num1 and num2, when calling the method, they are now called arguments, not parameters. So parameters are what we specify when declaring the method, while arguments are the actual values that are going to replace the parameters when we call the function or when we call the method. So you can see that as I already defined my method below here, I have just called the method. I don't need to write the same code which I already wrote to compare the two values. And then I'm storing the result. So this max which is returned from our method is what is going to be stored in this variable result, and then we are going to now print result. Now let's run the program again, and you see that we will have the same output. So you see the max is still returned as 3. Now you can see that within our findMax method, when we were declaring the method, we specified the return type as int, whereas with our main method, the return type is void. So void is a return type that we use when we are not returning anything from our method. So let me show you how we can use this. I'm going to change the return type of this our findMax method to void. This means when you have a method and its return type is void, it means you cannot return any value from that method. So this line return max is going to become an invalid line. Let's try to run the program like this, and we see that it is going to give an error. You see that we have received an error because we are trying to return max, whereas the return type of the method is set to void. So usually when you are using a method of return type void, meaning you are not returning any value from the method, what you usually do most of the time is that we can just print the result of this method directly within the method instead of returning it. So I will replace this with a print statement, and then instead of returning the max, I will instead just print the max directly from within our method. So I am now saying system.out.println max. So we are printing the max, and then within our main method now, or the body of the program, we will have to change some things. Like here we had to first declare this integer variable called result in order to store the value which was being returned by the findMax method. So we are going to now change this to, since we are not returning any value from our method again, it means we will have to cancel this, because nothing is being returned from the method and being stored in the result variable. And we will also cancel this line printing the value of result. Now this time around, when we simply call findMax and then we pass the arguments num1 and num2, it is simply going to print the maximum value at once instead of first storing it within a variable and printing the variable later. So let's save this and try to check the output. So we see we have just printed the max as 3. Now I'm going to modify our method a bit. I want to make the message here to be a little more explicit, I will say the greater value is, and then before printing marks. Now we can see the greater value is 3. That message is a bit more comprehensive. Now we are going to see where the beauty of using methods lies. As you can see, we don't even need to declare these two variables, and before using them, if you want, we can just specify the values which we want to compare here. I will just say 2 and 3 without needing to store them in num1 and num2 first. Now let's say if we want to find the max between two values, but we want to repeat that many times, so I will say I can reuse this same method find max as many times as I want, so long as I've already declared it, or so long as I've already created it once in the program. I've already written all the logic for comparing the two values and then displaying the maximum. I can simply call this as many times I want within my main method now. So I'm going to simply change the values. This time I'll compare 1 and 3. Now I will compare 210 with 84. Then I will compare 1034 with 987, and then I will compare 24 with 10. So you can see I have called this method 5 different times within the main method. This is what we mean by method reusability. I have just created the method once, but I can reuse it as many times as I want within my main method. You can imagine if I did not write this logic for comparing and displaying the marks within a method. For each of these different comparisons, I will need to write this ternary operator and then with the message printing the maximum value every time. So for these 5 times I've called the method, I would have written all the body of this find max method for all this number of times. But since I decided to create a method and put all this within the method, I can simply now call it by just writing the method name, and then I can pass different parameter sets or different argument sets at every time of calling the method. So this is the advantage of using method, permits code reusability. Now somebody trying to find the max of these two numbers just needs to write find max and specify the two numbers which he wants to compare without knowing what is happening in the background, even without knowing that in order to return this max we had to first maybe compare the two values and then before printing the maximum value laterwards. Now let's save the program and we are going to run it one last time. So we see all our different results are displayed as expected. This is how to use methods in Java. Hello friends, now we are going to talk about object-oriented programming in Java. So, object-oriented programming, or OOP, is a programming paradigm that uses objects to design applications and computer programs. It allows for organizing code in a way that is modular and reusable. We will cover the basics of object-oriented programming in Java, focusing on classes, objects, and inheritance. So let's look at some key terms which we are going to see in object-oriented programming. The first one is a class. A class is a blueprint for creating objects. It defines properties which are called attributes and behaviors which are called methods that the objects created from the class will have. We are going to understand this better when we see an example. The next thing I want to talk about is an object. An object is an instance of a class. When a class is defined, no memory is allocated until an object of that class is created. Let's take a real-life example to understand the relationship between classes and objects. We may have a school, and in this school there are several students. The administration of the school decides that each student should have a name, a student ID or matricule, and a specialty or field of study. This means we can view students as one class, and all the things that the student should have are the attributes of the student class. This means the student name, matricule, and specialty are attributes of this student class. Also, every student will have things to do like paying school fees, attending classes, and writing exams. These various things can be seen as the methods of the student class. Finally, we may have students who come to register in this school. For example, John and Mary. John and Mary will then possess all the attributes required for students of this school, and once registered, they can also carry out the different methods of the students class. In this case, John and Mary are known as objects of the student class. Let's now see how we can implement classes and objects within our program. So I'm going to use an example of athlete. I will define a class that contains attributes and methods for athletes, and we are going to also create objects of this athlete class which are going to use the attributes and methods of this athlete class. Now, as you can see in our Java program, every Java program must have at least one class. We already have one class, which is the quick Java class, which is also the class which contains the file name of the file in which we are. But we can also decide to add other classes which are going to contain special attributes and methods. So to create another class within this same file, I will simply have to go out of our quick Java class, and then we will create another class, or we will define another class below. So to create a class, I will write the class keyword first, class, and then I will follow it by the name of the class which I want to create. I want to create a class of athletes, so the name of my class will simply be athlete. And the name of the class should begin in an uppercase character. That is why the A of athlete is an uppercase A. Now I'll follow this with a set of curly braces. Now we have created an athlete class. Let's define some attributes of this class. So I will say attributes. Now in my athlete class, I want that every athlete which is created from this class should have a name, a discipline which represents the sport of that athlete, and the age of the athlete. So I will say the name is going to be a string. These attributes are simply like normal variables, but when we define these variables within a class, they are called attributes, not variables. So the name is going to be a string. And then I will say string name, which represents the name of the athlete, and then string again. This time around, discipline is going to represent the given activity or sport which that athlete carries out. And then now we will have the age of the athlete, which will be an integer. So now we have these three attributes for our athlete class. Now that we have specified the attributes of this class, let's now define a method within the class. So to define a method, I will say public, and then the method return type. This one is going to be of return type void, means we are not returning anything from this method. And then I will simply say greet. So this is a simple method of our class. Okay, so this is a basic class which we have defined with attributes and methods, and we have named this class athlete. Now let's see how we can create an object of this class. To create an object of a class, we need to go back to our quick Java class, since it is a class that contains the main method. The main method can be defined in one class in our program only. So the class which contains the main method is always going to be the main class of our program, and every other thing we do in the other classes, when we want to create or initialize these classes, we must come back to this main method. When we define a class, the class acts like a sort of data type for creating variables, like just like we have data types like int and even double. When we define a class, the class also becomes a data type because it can be used to create variables, just that the variables which are going to be created using these class names as data type are going to be called objects this time around. So those are what objects are. And the advantage of using class names over regular data types is when we have a data type like double, for example, this double, you can say double and then we give a variable maybe d, and we assign it a value of 3.4. So this is a double variable we have created, but a class enables us now to have variables which will be called objects, but these objects can store multiple information about a given entity. So let's see how to create an object now. To create an object, we will write the class name athlete, and then I'm going to say ath1, which means athlete1, and I'll say it is equal to new athlete, and then followed by a set of parentheses with a semicolon at the end. Now I am supposed to initialize the different attributes for this athlete. So I'm going to say, since we had in our athlete class, we have three attributes which are name, description, and age. So I need to give or assign values to each of these attributes for this given athlete. So I will say ath1, which stands for athlete1 dot name. I'm going to give him the name Leo Messi, which is the footballer of, and then now I want to give his discipline. I will say athlete1 dot discipline, will be equal to the discipline is football. Americans call it soccer, but me, I call it football. And then now his age, I will do the same thing, dot age. Since the age is not a string, I will not use double quotes. So I'm just going to say the age is 37. I think this is how old Messi is at the time I'm recording this video. And then I can also call the method which I define within my class the greet method. I can simply say that by writing the object name, which is ATH1, and then dot greet with my parenthesis after. Now let's save this. Also, the error says cannot find symbol discipline. It means I spelled discipline wrongly in one of the places. Yes, discipline is supposed to be with I, but I wrote it with E. Whereas here I wrote discipline with I, so that was the problem. Now let's try again. Okay, so we see this is the result of the method which we called, which says hello athlete. Now we have seen how to create a class and then define objects of that given class. We can see that when we create this object of this class athlete called athlete1 or ATH1, takes a lot of time to come and then write athlete1.name before giving its name, athlete1.discipline to give its discipline, and then athlete1.age to give the age. So we can make this process simpler by using a constructor. A constructor is simply a method which is defined within a given class, which is used to initialize the attributes of an object of a class at the same time which the object is being created. So let's see how to use this. The constructor should also have the same name as the class name, and it doesn't have any return type. So let's create a constructor for this athlete class. The constructor is going to say public and then athlete. We said it should have the same name as the athlete. It should have the same name as the class, and then I will follow it with a set of parentheses. Now within the parentheses, we are going to pass in some parameters which are going to be the attributes of this class, the name, and then the discipline, and finally the age. Okay, now I will follow it with a set of curly braces. Now the body of this method is simply going to initialize the values of all of these given attributes of the class. So to initialize the attributes, we will start with the name. I will simply say this dot name and then equal to name. So when I say this dot name, the this keyword simply enables us to specify that we are referring to the object which is calling this method at this given instance, and then this given object has the attribute name. So when we say this dot name, it means we mean the name which is the attribute of the object calling this method at the given instance, whereas the other name on the right hand side of the equal to symbol, it represents this name which is a parameter, because we could have called this anything. We could even call this like xyz. If we call this xyz, and then we can simply say name equals xyz, and we remove this. So we could say the name of this object is going to be xyz. But since we decided to name this parameter name, we decided to give it the same name as the attribute name, and name is an attribute of this class, but name is also a parameter of this method. So that is why we need to use the this keyword in order to avoid confusion from the compiler, so that the compiler should know that this dot name means this name which is associated to the this keyword represents the name which is an attribute of the class, whereas this other name on the right hand side represents the name which is the parameter of this method. So I hope you understand that part. We will do same for all the different attributes. So now we have initialized all the attributes of this given class. Now let's see how we can use the constructor to make the creation and initialization of the object and its attributes very easy. So here when I will first of all cancel all of this. At the level of declaring this object, when I say new athlete, I will just come within this parenthesis now, and then I will pass all the values which I want to assign to the attributes of this given object. And these values must match the exact order of the attributes as specified in the constructor. So in our constructor, we have the name first and then discipline, and then followed by the age. So when declaring the object, we will assign its values at once because we have already declared a constructor within the class. So for the name, I'm going to give the name Leo Messi, and then the discipline is going to be football, while the age will be 37. So you can see that now we have done everything on one line only. That is how useful constructors are, because it's the constructor that enables us to be able to just pass all these values one time like this, instead of having to create the object first and then we will say object.name equals this, object.discipline equals this, and object.age equals this. Now let's try to print one of the attributes of this object. I'm going to print the name of the athlete, so I will just say ath1.name. So you can see we access the attributes using the dot, and then we just write the attribute name. We see the name is given Leo Messi, and then this other message down is simply the result of this greet method which we call. Now one more thing I want us to do in our athlete class is that we will cancel this greet method. First of all, it is a bit useless. I want us to declare a method that is going to display all the values of this athlete attribute. So let's create this method I'm talking about. I would say public void is not going to return anything because we are going to simply print out everything within the method, and I will call the method display details. It's not going to take any parameters. I'm going to now print the different attribute values for the object which is going to be calling this display detail method. Okay, so now we are finished with this method. The method simply displays the values of the different attributes of the given object, which is going to call the display details method. We are saying name equals this dot name, discipline this dot discipline, and then age is this dot age. Now let's go back to our main method. We are going to, instead of calling the greet method, we are now going to call the display details method. We have athlete1.display details, and then before I want to create a second object of this athlete class. The classes are reusable, just like with methods, meaning that when you define a class once, you can create as many objects of that given class as you want. So that is what I'm going to do. I will create a different object or a second object of my athlete class the same way I did with the first object. This time it's going to be athlete2, ath2, and then I'll follow the same procedure, new athlete which is a constructor. This time around, the athlete I want to create is LeBron James. The discipline is going to be basketball. And then age, I think his age is 39 at the time I'm recording this video, so I'll just put 39. Now we are going to also call the display details method on this given athlete. So I will change this to athlete2.display details. Now let's check the result. Okay, we see this is for athlete 1. Name is Lionel Messi, discipline is football, and age is 37. And then for athlete 2, we have the name LeBron James, discipline basketball, and age 39. So that is how to use classes and objects in Java, and these are the basics of object-oriented programming. I hope you found this video helpful. Hello friends, in this video we are going to talk about inheritance in Java. Inheritance is a key feature of object-oriented programming that allows a new class to inherit or use properties or attributes and behaviors or method from an existing class. This promotes code reusability. With inheritance, there are two main terms which we need to know. The first one is the superclass. This is also called parent class, and this is the class from which properties are inherited. The other term is the subclass, also known as the child class. This is the class that inherits from the superclass. So with inheritance, the subclass is able to use attributes and methods which are defined within the parent class. Now let's see inheritance with an example. Within this program, I already have an athlete class which I created in the previous video. This athlete class stores information about given athlete. Each athlete has a name, discipline, and age. And then we have a constructor which we use to initialize the values of the attributes for the given athlete objects which are going to be created from this athlete class. So this is the constructor. And then we also have an extra method for displaying the details of the object which is going to be created from this athlete class. Now let's use inheritance in this video. We are going to create another class which is going to be a class for footballers only, and we are going to name this footballer class. And this new class is going to inherit from the athlete class, meaning that it is going to take all the attributes and methods defined in the athlete class, but we are going to add an extra attribute which is unique to the footballer class. So each footballer is going to have a name, discipline, and age, and the new extra attribute which we are going to add will be unique to this footballer class, which is the position, meaning the given position on the field in which the footballer plays. As we know, there are some sports like tennis or boxing where we have maybe just one player which is playing at a given time. It is not a team sport, so we don't have different positions on the field for playing or for practicing those given disciplines. Since it is unique to footballers only, it means everybody created from this class is a footballer, and each person involved must have a position. So it makes sense to give this attribute only to a footballer class instead of giving it to the athlete class, since we know that there are some athletes who are not going to require any position because maybe it is a one-man sport or discipline which does not need different people at different positions on the field. And that is why we will create an extra class footballer, so that every footballer which we will create from this class will be able to have all the required attributes we want without needing to add an extra attribute to the athlete class, which will be useless for many of the objects. So I'm going to create a new class, as I said, which I'm going to call footballer. So I will say class, and the name of the class is footballer. So this is the class we have created. And then, as we said, the footballer class is going to inherit all the properties and methods from the athlete class. So this is the footballer class we have created. Now, in order to specify that this footballer class inherits from the athlete class, we need to write a keyword after the class name footballer, give some space, and then we write extends. This is a keyword in Java. After extends, we specify the class which it extends from, which is the athlete class. Extend simply means footballer inherit from athlete. That means every property and method which is in the athlete class can be used in the footballer class, so or by an object of the footballer class. Now, since the athlete class had a name, discipline, and age as the attributes for the given object, we agreed that we are going to add an extra attribute for the footballer class, which is the position, and it is going to be a string. So I will say string position. And as you can see, we don't need to declare the other attribute again because it's already going to be automatically inherited from others into this footballer class. Now let's write our constructor for the footballer class. We already talked about what constructors are all about, so you should already be familiar with that. So I will just say public. The constructor should have the same name as the class name, so I will say footballer. And this time around, footballer class is going to take 4 parameters because the footballer class has 4 attributes in total, 3 which are inherited from the athlete class and 1 which is unique to the footballer class, which is the position. Okay, so this is the constructor for the footballer class. Now within our constructor, I will want to initialize the values for the given attributes of the footballer class for the object which is going to be created using this constructor. So instead of writing this.name equals name, this.discipline equals discipline, and this.age equals age, which we already did in the parent class, which is the athlete class, we can simply use a keyword known as the super keyword in order to call the superclass constructor directly into the subclass constructor. So I will say super, and then open my parenthesis. Within the parenthesis, I will specify the attributes which I want to call from the parent class or from the superclass, which are the name. I want to take the name, discipline, and then the age. So this line simply means I'm going to the constructor of the superclass which footballer class inherits from, and then from the constructor of this superclass, I want to initialize the name, discipline, and age the way it's already done in this constructor of the superclass, so that I will not have to rewrite the same things within the constructor of the subclass. Now I will initialize the position attribute. Since it was not in the parent class, we must write it ourselves in the constructor for the subclass. I will say this dot position will be equal to position. I repeat again one more time, the age, discipline, and name are being imported from the constructor of the superclass, as we can see on this line here, whereas for the position, we are initializing it ourselves on this other line. So this is all for the constructor of the subclass. Now the superclass also has this method that displays the details of the athlete. We are going to override this given method within our subclass. So what we mean by overriding a method is we are going to take this method from the superclass and then we are going to call it within our subclass, but we will change the implementation of the method, or in other words, we will change the body of the method. The method will still have the same return type, name, and parameter set, but it is going to have a different body. That is the meaning of overriding a method. So let's override this display details method in the subclass. And you should know that if we don't override this method in the subclass, the method will still be available in the subclass, but it will be exactly the same as it is in the parent class. But we don't want it to be exactly the same because, as you can remember, we added an extra attribute which was the position. So we want to also add a line that is going to display the position of the given footballer as we display the other attribute, but it is not done in this method for the moment. So that is why we will have to call it in the subclass and then override it. So I'm going to say public and then void. We will write the method name, which is display details. Now we could also write all of this, or we could just copy it, lines of code from the constructor of the superclass, since it is what we want to also do in the subclass. But in Java, there is actually an easier way to go about this. I will also use the super keyword here, just like we did with the constructor. This time around, I will say super and then dot display details. This simply means that I want to go to the superclass and then access the method called display details within the superclass. And it is going to call the display details method from the superclass, meaning that everything which is in the body of the display details method is going to be copied in the body of the display details method for the subclass. So instead of copying and pasting all those things, I can just use this one line to do that. And then now I'm going to add an extra line which is going to also display the position of the given footballer. Okay, so now we have overridden the display details method in our subclass. We first called the display details method from the parent or from the superclass into the subclass in order to copy the body or everything that is in it to avoid repetition. And then we added this one line. And one thing we need to add when overriding a method in Java is an annotation. An annotation is simply a sort of comment we are writing, but this time around we are writing the comment to the compiler or to the IDE, not for the use of other programmers or ourselves. So it is something that it doesn't really affect our program or our code, but we write it to just indicate to the IDE or the compiler that this is what we are doing in this given point in time, so that the IDE or compiler can better understand what we are trying to do in the program. So one annotation we are going to use here is the override annotation. I will write it by writing an @ symbol, and then after that I will write override. It begins with an uppercase O, override. So this simply indicates that we are trying to override a method. This is not obligatory to use, but it is just a good practice to use the override annotation before overriding a method. But if we don't use it, it will still work. But as I said, it is a good practice to use it. Okay, now I think our footballer class is complete. We created a footballer class and then we made it to extend or to inherit from the athlete class. We added an extra attribute, the footballer class. In the constructor, we also initialized this extra attribute. And then finally, we have displayed the details of the footballer, including the details containing the extra attribute which we added. So now let's create an object of this footballer class. Or actually, in our main method, we will first create an object of the athlete class and then we will create another object for the footballer class. So to create an object of the athlete class, I will say athlete, and then I will say 81 for athlete 1 equals new athlete. The new athlete I will create is going to be Serena Williams, the popular tennis woman. And then next we have to specify her discipline, which is tennis. And then finally the age. I'm not very sure of her age, but I think she should be something like 41. I should have done a little bit of more research, but it's too late now. So I'll just say 41. I'm just assuming that to be her age. I'm not really sure. And then now I'm going to create an object of the footballer class. I will say footballer. And then the object name is going to be F1, which stands for footballer 1. Or let me actually say FB1. And the footballer I'm going to say new footballer to call is constructor 2. The footballer I'm going to create will be Cristiano Ronaldo. So I will say the discipline is obviously football. And then his age is 40. Position is, I will just say forward. In order to avoid this from moving to the next line, I will abbreviate his name a little. So let me just say C Ronaldo because I prefer it to be on one line only. Okay, so I have Cristiano Ronaldo. Discipline is football. His age is 40 and he is a forward. You see that with the tennis woman, Serena Williams, athlete 1, we did not put any position because position is not an attribute defined in the athlete class. For example, it doesn't make sense to give a position to a tennis player. That is why we actually needed to create a different class footballer since position an attribute that is unique to footballer as compared to other sports. It's true that there are also other team sports where position is important, but I was just saying the general sense where it is not all disciplines that are collective sports and require positions. Now let's call the different methods of these classes. So I will first call the display details method from the athlete class at1.displayDetails, and then I will say footballer1.displayDetails. I'm going to give a bit of space between these two, so I will add a line that prints nothing. So this line is simply to leave an empty space in between the two different display details that will be printed. So you can see that with athlete 1, I have written athlete1.displayDetails and fb1.displayDetails. Display details is the name of the method from these two classes, but the output or the results are going to be actually different because we have overridden the display details method for the footballer class, which means it is going to be actually different from the details that will be displayed in the display details method of the athlete class. Now let's save this and we will check the output. Okay, we see this is for the athlete class. We have the athlete object. We have name Serena Williams, discipline tennis, and age 41. While for the footballer class, the object of the footballer class, we have name Cristiano Ronaldo, discipline football, and age 40 plus position, which is forward. So we can see that with inheritance, we are able to perform method overriding. That means we have a given method in two different classes, in the subclass and in the superclass, but the implementation or the body of that method in the superclass is different from the implementation of the same method in the subclass because it has been overridden. And we can also see that with thanks to inheritance, we had our class which is athlete class with all of these attributes and methods, but we wanted to create another class which was the footballer class that was also supposed to use all of these similar attributes or information that are already found in the athlete class. But thanks to inheritance, we did not need to rewrite all of those lines of code again because inheritance permits us to already use all of the attributes and methods defined in one class within another class. So that is the main advantage of inheritance. It permits us to do what is called code reuse or avoid unnecessary repetitions. So guys, that is inheritance in Java. I hope you found this helpful.